Hello and welcome to episode 24 of Chemistry in 15 Minutes or Less. My name is Audra and this review lesson is on chapters 10 and 11, part 2, Energy and Changes in Matter. To start us off, we are going to look at this phase diagram for H2O or water, which is probably not my best drawing of all time, and it's not entirely accurate or completely filled out yet, just so that way we could look at where the three states of matter are on this graph. Over here, off to the left, we have solids. This big section in the middle is liquid because it's water. And down here we have gas. This is a graph that goes by pressure on this side and temperature down on this axis. So, as you can see, this is where everything falls in, and there are a couple of points that you might notice that we are going to need to talk about and label. Pick a different color. Basically, we have a couple of points we'll talk about. Triple point, normal boiling point, critical point, critical pressure, also critical temperature, just circle it, and then normal melting point. So that's a lot of writing on this, but they all are pretty simple. The triple point here is a point at temperature and pressure, as you can see by the graph, where all three states of matter can exist at the same time because of the way the conditions are. These are optimal conditions. As you can see, it's less than 1 atmosphere, which is the standard temperature, and it is about where the quote-unquote freezing point would be for this liquid, even though it's not the normal melting point or freezing point. They're the same thing. But this is where all three states of matter will exist at the same time. The normal boiling point and the normal melting point or normal freezing point are exactly what they sound like. In this case, that would be, 0 degrees Celsius versus 100 degrees Celsius, because it's at 1 atmosphere. Wherever that is where the normal points will be, because that is standard conditions, which we'll talk about in the next episode. But also critical pressure is the maximum pressure that it can handle, and critical temperature is obviously the most temperature it can handle, and they meet together at what's called the critical point. Or basically, after this point, it is almost impossible to distinguish these states of matter from each other. It's what's called a supercritical fluid, where it's not really a liquid, it's not really a gas, because it has gone off the graph at this point and is somewhere. We didn't spend a lot of time going over that, but it's important to note those, and that all of these normal points happen at 1 atmosphere. And since we're looking at a phase diagram, all the phase diagram is a graph of pressure versus temperature that shows the conditions under which the phases of a substance exist. So now what we'll quickly talk about is a quick diagram to show you the names of the phase changes. Now if we have a little triangle where we have gas up at the top, solid over here, and liquid here, we have changes that can go in all directions. Now, for solid, if it's a solid already and it's becoming a liquid, we already know what that is. That's melting. If it's a liquid becoming a solid, we can either call that freezing or solidification. That's the more scientific name to say freezing point or freezing. And over here, when a gas is becoming a liquid, we know that probably already is called condensation. Again, that's gas becoming a liquid. And when a liquid's becoming a gas, we call that vaporization. Now, in our class textbook, it does say evaporation, but that's technically not correct. The whole process of boiling and evaporation is called vaporization. It's more important because evaporation, like we talked about, is only the top coming off. Vaporization is all of it moving from one state to the next. Now, some of these that you might not be familiar with is when a solid is becoming a gas, which is a process called sublimation. Think of dry ice, which is solid carbon dioxide, going straight from the solid form to the gaseous state, which is how we have fog machines. Or, on the other hand, we also do have when a gas becomes a solid, and that is called deposition. Now that we have gone over phase changes, it's important to note that energy comes along with phase changes, which means we have to find a way to be able to calculate the change in energy between changing of states. That is called molar enthalpy, which we spent some time on in class. He was kind of confusing and vague with, but the equation that we need to know to use for this is the heat of fusion equals the energy of the change times the molar mass of the substance over the mass of substance that is changed. This comes out of the equation where it's heat of change over moles, but you can change the moles into mass and put the molar mass on top, because as you know, N equals molar mass over mass, which means that these equations are the same, but instead of having this, you just substitute these two parts of the equation in, which is where you get the M and the M from. It's pretty simple. We do a couple of problems. If you want to find some of the practice problems in the textbooks to go over, I would recommend it. I don't know a whole lot about it because he did really, really gloss over it, but that is an important formula that you should know. Some other things that are also important to talk about, is I know we talked about it earlier in the chapter, but it's not in one of my videos, is specific heat. And specific heat is just the amount of energy required to raise 1 gram of a substance up 1 degree Celsius. But with that, that should actually conclude episode 24 of Chemistry in 15 minutes or less. Feel free to leave questions or suggestions in the comments below, and be sure to follow the in-video links, check out the playlist, or head over to my channel for more videos on chemistry review. As always, I hope this was helpful, and have a great day.